Yuri, what's the next step?
Well, I mean, first of all, we could not have asked for a better sample. I mean, to actually record, like when Mike and I woke up on sunrise.
My father had an opinion of this kind of stuff. This is a man who never graduated or never made it past 8th grade. You shit long enough in your backyard, pretty soon you're living in your own shit.
Yeah. Yeah.
Yeah. You can talk nano, you can talk this, atmosphere, ground, whatever. Yeah, shit long enough in your backyard, you're gonna live in your own
Here's
shit.
a question. How
You
many?
get 800 billion people shitting in their own backyard with everything,
Some of the nanomaterials, most of the nanomaterials that we're now focusing on in terms of identifying them in use for weather modification and climate engineering, their mode of action for damaging tissue is the generation of reactive oxygen species. And this is in tissue, we're especially concerned with the recent publications documenting the effects of reactive oxygen species generated by nanoparticles in the frontal cortex. So this, and leading to dementia. What is your knowledge about ROS generation by nanomaterials or nanoparticles, first of all?
Well, let me back up a little bit. In
Okay.
terms of reactive oxygen species, everything we know at present suggests that generation of reactive oxygen species is the cause of aging, cause of almost every disease that we know. Certainly dementia, but other diseases as well.
This is real science. This is real science. And on a topic as important as lead poisoning. That's one thing, I mean, these are like, this is a big
There are other
freaking
techniques
deal.
that we can apply to these samples, like for even those micron scale aggregates of particles. We can subject those things to things like nano SIMS, nano secondary ion mass spectrometry, where we have a very, very pointed beam that will bombard a sample, ablate materials from the surface of even small particles like this, and then those particles that are released go into a mass spectrometer, and then you can get information on charge and mass. And from charge and mass analyses, with lots of things like, especially polymers, smaller atomic mass unit compounds, you can start to identify what is being ablated from these surfaces. And in fact, you can also do elemental mapping or molecular mapping with nanosims, where a particle like that, you would see at very, very high resolution the elemental composition of the materials there. So that is available at a couple of the national labs that I used to work with. So I'm going to probably continue on after we collect the TEM analyses, transmission electron microscopic analyses, move on to different spectroscopies that will give us even more information about the nature of these materials.
Reactive oxygen species are generated by all kinds of things. Our normal metabolism in mitochondria in our bodies generates reactive oxygen species. Our body has a whole host of defenses against it. Various enzymes, superoxide dismutase being one, catalase, glutathione. These are mechanisms our body has to control these reactive oxygen species. Now, we're all exposed to microwave level radiation to some degree from the sun, independent of all these extra things we've added. And when you have nanoparticles in the body, they are small enough so they go everywhere. A lot of the nanoparticles, not all of them, but a lot of them have metal ions. Metal ions are potent generators of reactive oxygen species. The the real problem is it's almost like the EMFs. There has been a lot of excitement about the potential of nanoparticles for diagnosis, for administering drugs, for all kinds of useful purposes. And there's been very little attention to the dangers that nanoparticles pose. And there are very serious reasons to be concerned about those dangers. Not only the metal ions, many of which we know to be very toxic, but the fact that the size of these particles is so small that there is no barrier to them in any part of the body. They cross the blood-brain barrier, they cross cell membranes, and where they're acting and how they're acting is still relatively poorly studied. But we do know they generate reactive oxygen species. We know that that's dangerous.
Here's a question for my science fans. How many virus particles are present on the Earth right now? And I'm giving an estimate.
Are you including the human species?
Ha.
Oh, I'm not kidding.
Yeah.
Are
well,
you including the human species? Because we are the virus.
I'm actually
just like the
talking
movie.
about something on the order of 50
We're the virus.
nanometers.
We're the only species on this planet that's fucked up enough to fuck up the planet.
But,
Well, we just analyzed 3 different areas. This particle seems to be high in aluminum.
oh, good.
It's a large flake, though.
Yeah.
And then there were 3 large carbon-containing particles nearby.
This is awesome.
And this has some silver, too, so which we haven't seen for a while.
Yeah, in terms of now the aluminum signatures that we're getting from the glass fibers themselves,
This is
thing
much bigger.
Much bigger.
So look at that.
Yeah, that's
So-
the aluminum.
It's easily 3x the silicon.
Yep.
And I think the silicon and aluminum are pretty similar in the glass. I'll grab a spectrum right adjacent to this, and you'll see that.
And so now you can see how important it is not just to take a couple of images or find a couple of particles, but really do a thorough.
So here, if you look at just the
job.
glass fiber, silicon is significantly taller than aluminum. So that particle there is mostly aluminum.
So I mean that's what we're looking at here. That if these things bear out, if your data bears out that these are engineered, synthetic nanoparticles
I'm sorry,
potentially distributed into our atmosphere.
Yep, just another example of man fucking up this planet.
Yeah, it's true, right?
I mean, I've given up on the pain and anguish it causes the same people in your own species. Fuck that.
Yeah.
They don't care.
These are likely to be the causative agents of dementia, accounting for the rapid increase in that disease, those diseases, Parkinson's-related dementia, Alzheimer's-related dementia, and the others now that are newly arriving. And these are not some sort of new spectral type of analysis. This is histological sessions of brain tissue showing the damaged tissue. So, has gone from 1 in 40,000 people in 1950s to 1 in 50 people now in the United States, the male population between the age of 50 and 70. And that's in both cases. So look, we have, that is not just from some redesignation or genetic drift. This is an environmental hazard. These things cause dementia by generating reactive oxygen species and oxygenating cerebral fluids. Third symptom.
Yep, it's true.
And it's published in the medical and scientific literature. So what are we going to do about that now?
Us.
Yeah,
We're
let's.
just going to continue destroying the planet, and then it's going to kill us.
Well, us, you and me, and the others here, we're going
We're
to
gone.
continue to
We're gone.
apply the scientific method to show that we have an issue.
Oh, we have an issue.
So now he's inserting the sample holder into the interlock. This is so you can go from ambient pressure to high vacuum. And it takes about 10 minutes for this.
So measuring this one right here, this is below 70 nanometers.
Right. Good. In
Okay.
the precipitation samples that we've seen in the past, the aluminum oxide particles that we've been seeing are the order of 40 to 60 nanometers. So that's consistent with the size that we've seen from precipitation events. Again, these samples were collected directly from the air.
You can put this in your documentary.
It is.